Okay, in section 5.4b, we're graphing rational equations, and your book didn't put this in a regular section, it just kind of did it as an extension, so we're going to do it. If I want to graph this on a coordinate plane, let me go ahead and draw one, okay, x and y. This is number 3. And there's different ways I need to look at this, okay? There's some different things I need to do, and I've loaded some notes on course sites that might also help you with this. First of all, do you remember how we were always checking the domain in some of the problems in the last section? Well, if we look at the denominator and we set denominator equal to 0, we'll find out that we cannot let x, if we solve that, we cannot let x equal 1. Well, okay, that means that the denominator would be 0. What does that look like on our graph? Well, this is called an asymptote. And the asymptote, I'll draw it in blue, is at x equal 1. It's a vertical line through 1. And what's going to happen is as our values get close to this asymptote, they're either going to probably go up to infinity or negative infinity. We'll kind of see what's going to happen in a minute. Now, something else that we did in the last section was we checked to see what was okay, so I've got an asymptote. So I find that by setting the denominator equal to 0. All right. Another thing we did in this last section was we set the numerator equal to 0, and that helps us find our x-intercepts, our zeros. Those are our x-intercepts. Okay, so we take if you look at the top of this, it's just x plus 1. We'll set it equal to 0. Oh, we have an x-intercept at x equal negative 1 if I just subtract 1 from both sides. So at x equal negative 1, there is an x-intercept. Now, we have not got into this yet, but there is something called, we have horizontal asymptotes. Okay, so I'm going to go ahead and explain those. When we're graphing rational expressions, we will talk about this in class a little bit more, but and I've loaded a video on it to explain it further. But we look at the leading term in the numerator and the denominator, and I have x to the first over x to the first. Here, the exponents are the same. So this is what we call an Eats DC. There's Bobo Botten Eats DC, and there's another video to explain it. This happens to be an Eats DC problem. I'm just going to discuss this one problem and not go into all the other detail here. If the exponents are the same, that's what exponents is the E, R, A, the same, that's what that stands for. You divide the coefficients of those two terms. So we're going to divide the coefficients. Okay, well, what are the coefficients that I'm supposed to divide? They're the coefficients of these two x's that I was looking at. And both of them have an invisible 1 on the top and 1 on the bottom. In front of the x, there's a 1 on top, 1 on the bottom. So my horizontal asymptote is y equal 1 over 1, which is y equal 1. I'm going to draw that in blue. That means at y equal 1, that's a horizontal line through 1, there is a horizontal asymptote. Now, once I get this, it's probably still going to be helpful if I go to my calculator and get a couple more values, or I could even plug some numbers in and get some values. But what ends up happening, I can tell what's going to happen, right? You see this x-intercept here. It's going to approach this line, the graph is going to come and get really close to this line here, and it's going to go down and get really close to this line here. That's what an asymptote is. A graph approaches it but never actually touches it or crosses it. Now over here, what's probably going to happen is and I can check this in my calculator, is I'm just going to put a little dot, I'm going to go ahead and draw it in here, probably going to get something like this. And usually on these rational graphs, they're kind of like catty-cornered to each other, if that makes sense, kind of diagonally across from each other. I could check this out. Let me look at a number like 2, okay? If I plug in x is equal to 2, y would be 2 plus 1, which is 3, over 2 minus 1, which is 1. So I would get the point 2, 3. Again, I could have gotten this off my calculator. So at 2, 1, 2, 3, yeah, it's right there. Usually what happens, and let me check another one. You could check a lot of these, and it would be quicker to do this on your calculator. let me plug in another one. Let me check a point like 1, 2, 3, 4. Let's check 5. 5 plus 1 would be 6. And 5 minus 1 on the bottom would be 4. So it would be 3 halves. So at 5, we're at 3 halves, which is 1 1/2, which is about right where I got it, right? We can look at the calculator and see where these points are, but once you get a couple of other good points, you can sketch your graph and kind of be done with it. So this is number 3. We've actually got this filled in pretty well here. I thought we'd take a look at number 9. Number 9, it says h of x, which you could just write y equal if you wanted to, x squared plus 1 over x squared. Okay. So now let me go ahead and draw a little coordinate grid and put some marks on it. All right. Now, the things that we check, first of all, we can set the denominator equal to 0, and that's going to tell me my asymptotes. Asymptotes are always vertical lines. So we take that x squared, that's the denominator, and we set it equal to 0, and if you square root both sides, you get x equals 0. So I have an asymptote at x equals 0. That means a vertical line through 0. So my asymptote is actually my y-axis here. Now, if there are any x-intercepts, we would find them by setting the numerator equal to 0. Okay, so let's do that. X squared plus 1 equals 0. If I subtract 1 from both sides, I get x squared is negative 1. Ooh, if I square root that, that's an imaginary number. That's not a real number. So there are no real x-intercepts. Okay, so I'm not going to have any x-intercepts on this graph. The other thing I can do is check the horizontal asymptote. There are some other things to check, but they're just giving you some really simple equations here, so I'm just going to keep it simple. To find the horizontal asymptote, I take the two leading terms. I'll circle them in green here. This is the x squared here and the x squared here. It's the term that has the largest exponent on it in the numerator and the denominator. Now the exponents are the same. They're both 2's. So if I'm thinking Bobo Botten eats DC, this is an eats DC. Exponents are the same, and the DC part stands for divide the coefficients. Well, what are the coefficients up there? Well, both of these numbers have an invisible 1 out front. So it's y equal 1 over 1, which is y equal 1. So I'll have a horizontal asymptote at y equal 1. Okay. So now if I go to draw this one, this is kind of a because it has a square in it, it's not going to be diagonally across on the graph like it was for number 3 that was done previously on this video. Probably here, since I don't have an x-intercept to peg this down, I should probably go type this into my calculator, and when you type it in, make sure you put x squared plus 1, the numerator, in parentheses, and then you put this on your y equal, and then divide it by x squared in parentheses, okay? When you do that, you'll start getting some points that you can graph, and you can kind of see what's going to happen. For instance, if I plug in x is, let's see, if you just even type this on your calculator, you're going to see what's going to happen. You can get some points and graph them, but you can see from the calculator what's going to happen is this right here. So you could just sketch that in by looking at your calculator, and if you wanted to verify some points, you could look at the table of values and plot some points on that to get it as accurate as you'd like for your sketch. But this is how you would do number 9. Sometimes we have something called a hole in the graph. And we have a hole in the graph if we were to have a factor that canceled out of the numerator and the denominator. And they're not giving us any of those here, so we don't have to worry about that here, but we will be talking about that at some other point as we look at these type graphs. So here's a couple here. So do these things. Check for an asymptote by setting the denominator equal to 0. Then set the numerator equal to 0 to find your x-intercepts. Then check for a horizontal asymptote by looking at your terms and using the memory device Bobo Botten eats DC, and that's explained in another video, and we will have talked about it in class. If you're absent, watch that other video. So do this, and then you're going to need to check for some points, which you can get out of the table of value of your calculator, or you can plug them in by hand. It's just that, plugging them in by hand can be kind of a pain. for instance, I could do some that weren't so bad here. Write in purple up here. What if I chose x equal 1? Well, 1 squared is 1 plus 1 on top is 2, and then 1 squared on the bottom is 1. So that gives me the point x is 1, y is 2. Well, that's about right here. Okay, so it worked out pretty well. If I put in negative 1, I would get the same thing. I would get negative 1 squared is 1, plus 1 is 2, and then negative 1 squared on the bottom would be a positive 1, and 2 over 1 would also be 2. So I'd have the point negative 1, 2 as well. So you could, there's sometimes you can find some easy numbers to plug in to help get these points, but a lot of people just would rather get them off the table of values of their calculator rather than sit there and play around with the numbers.